that if we have similar shapes, the two things that have to occur is that all the corresponding angles are congruent. They have the same exact degree measure. Oh, you can't really see that good, can you? All right, and the ratio of their lengths are also equal within those corresponding sides. So very much what you did last night for homework. We did a bunch of these last night for the homework. The ratio that takes you from one to the other. All right, what do we multiply by? And then a dilation is, again, us just changing the side of a shape. A reduction is the official word if we shrink it. And that's when our scale factor is less than a 1. The enlargement is the fancy math word for when we make it larger, and that's when our scale factor would be greater than 1. Okay? All right, so when we look at these guys here, just to make sure we understand that, and then we'll kind of get into the new thing that we're going to be doing today. So let's consider the two rectangles shown here. Are they similar? So we just talked about what that means. The first thing that has to be true is their corresponding angles must be congruent. So if we look at these corresponding angles, like angle A and angle E correspond to each other, would we be able to say that those are congruent? Yeah, because what are both of those angles going to be? We would know those degree measures. They're what, Armando? Yeah, these are 90 degrees. Aren't all of these angles 90 degrees? So in terms of are the corresponding angles congruent, then the answer to this is definitely yes, because they are all 90 degrees. So we satisfy that first condition. But if we go back up to our gray box, we've satisfied this one. The corresponding angles need to be congruent. The second thing is the ratio of their lengths need to be the exact same thing. So when we come down here now, if we look at the blue triangle, so the big one, that has a length of 3, just up 1, 2, 3. If I go to the red triangle, that has a length of 2. So the first ratio is a 3-to-2 ratio if I go from the big triangle to the small triangle. When I come over here to the red triangle, or not triangle, rectangle, if I go to the top, so now let's go across the top, now I would have 1, 2, 3, a length of 4. You have a different problem? Is that the homework? Oh, that's the homework. See him being here on time is really throwing me off, I'm not gonna lie. So apologize. All right, here we go. I'm have to erase all of that again. Thanks, Armando. At least if we get this done, that'll be the homework. And now that we've wasted some time, maybe we won't have homework tonight. All right, let's try this again. Come on, Lily. You gotta speak up over there. Just talking to myself here. Okay, let's try this again. I'll go through this quicker. The big gray box up here, all these little refreshers. So we just talked about it. But in terms of what I was highlighting, similar shapes, what we said to be a similar shape, all the corresponding angles need to be congruent. All the ratio of the lengths need to be the same from one to the other. That scale factor, that's what we just spent last couple of days doing, the ratio to go from one to the other object. And then you probably saw me circle here a minute ago, if we have a reduction, a dilation is when we make the shape bigger or smaller, either or. If our scale factor is less than 1, we made it smaller, we call it a reduction. If our scale factor is greater than 1, we made it larger, and we say it would be an enlargement. Now the first problem. So this, everybody kind of understood, I think. You can kind of look at these angles, and I was talking about how these are all 90-degree angles. So since these are all going to be 90 degrees, we definitely satisfy the idea that the corresponding angles are congruent. All right, so that's what you're writing now in letter A, now that you have a letter A to write in. So 1A, you're going to say yes. And then because all angles are 90 degrees. All right. Then what we were on is, are the ratios of the corresponding sides equal? So we'll do the left-hand side compared to the left-hand side. So if I'm at D, I go up 1, 2, 3 steps. So this has a length of 3. The red rectangle, if I start at the bottom, I would go up 1, 2, giving this one a length of 2. So one of the ratios on the sides is 3 to 2. If we go across the top, I would have 1, 2, 3, 4 steps across the top for the blue one. And then on the red one, I'd have 1, 2, 3 steps across on the red one. So again, if I go bigger to smaller, so when I set up my first ratio, I went the big rectangle to the small rectangle. So if we do that again, in this case, I would get a 4 on top and a 3 on the bottom. Are those equal to each other? No. So since these, in fact, are not equal to, so actually write in the not equal to symbol, we would now say, are these ratios of the corresponding sides equal? And you would say no. And then really we could just write this. So if I were to ask you, and this is maybe counterintuitive to your definition of similarity before you would have come into the class, if you see any rectangles, it'd be easy to think they're similar, and in some ways they are. But in a math definition, we would not consider these guys similar shapes because even though their angles are congruent, their ratios of the corresponding sides are not equivalent. Okay? So those are those two conditions that we're talking about up here. Corresponding angles are congruent and the ratios of their sides better be equal. All right. All right. So now in these next ones, we're actually going to kind of sketch some of these things in now. So it says consider a triangle ABC to the right. So we have that one drawn in. What I want you to do is draw in a dilation. What we define dilation to be above is making our shape bigger or smaller. What I'm going to do for triangle ABC, centered at 0, is with a scale factor of 2. So what kind of dilation is this going to be? A reduction or an enlargement? Yeah, an enlargement. So we should be drawing in a bigger triangle. And then you're going to label that thing A prime, B prime, and then C prime. So little tick marks means that's our new shape. This is the original without the tick marks. And then these little tick mark means that's going to be original. So now, kind of the first time we've done one of these, but when I tell you that the center is 0, that's an important piece of information that we want to know. So put a dot at 0, 0, because that's where everything is going to be based off of. And then what I'm going to have you do is, it's really kind of a slope idea. We'll start with point C first. So if I want to go from this point to point C, I would go up 1, 2, and then I would need to go left 1, 2, 3, 4. So my slope to get from 0, 0 to point C is up 2. Do not reduce these either. All right, leave these with their overall values. And then I would have gone left 4. So now think about what a scale factor is. All right, it's our ratio. It's what we're multiplying by to go from one figure to the next figure. So if my scale factor for this next one is going to be a 2, what I'm simply going to do is multiply how far up I go and how far left I go by 2. I basically want to double the length that I just counted off. So the new one should be up 4 and then left 8. So now go from the exact same point. Let me do this. I think blue will show up good. Same point of 0, 0. Now I want to go up 4. 1, 2, 3, 4. And then left 8. 1, 2, 3, 4, 5, 6, 7, 8. Make a big fat dot right there. That should be C prime. That's going to be the new triangle length. Now, I don't have, I wish I hadn't, maybe I do. I couldn't find it this morning. But notice how now, look at 0, 0. I'm going to draw this in. Don't draw this in because I'm going to erase it as soon as I draw it. And I just want you to kind of see what happens. If I did this correctly, notice how the center of origin, the original point C, and that new point C, see how they line up perfectly in a straight line. That has to happen. If it doesn't, then we screw something up. Okay? So that's our new point C. You're going to follow those same steps for the other 2 points. So let's do A next. So if I want to get to point A, I have to start at 0 and then just count off what I need to do to get to point A. So to get to point A, I'm going to go down 1, 2, 3, 4. So right now my slope is down 4. And then I would have to go right 4. 1, 2, 3, 4. So if that's what I normally do for the original figure, and I now want to double it, then we basically just double it. So we multiply those by 2. That means you're now going to go down 8, right 8. So I'll do this one in the blue. So now I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 down, and then 1, 2, 3, 4, 5, 6, 7, 8 to the right. This you're going to label, that's A, as A prime. Do kind of an unofficial check. The point 0, 0, the point A, and the point A prime should line up perfectly in a straight line. You don't want to draw it in, but you should be able to kind of visualize that and then see it. Okay? All right. Do the next one. Do B. See if we're understanding. Because then you should have the eye test. Will tell you if you did it correctly. Find B primed and then connect this C prime point up here. Connect the A prime point, and then wherever you ended up with B primed, and see if it is pretty much that triangle, just expanded and doubled the size. All right. All right, again, you'll probably know in your head when you draw it in if it looks right. Okay, it should just look correct. It should look good. Okay. If you're done, we're going to give it a go. If not, you can continue on, see if you got it right. But I now need to find this new B point. So I want to start at where I'm centered. I'm centered at the 0, 0. I would have to go down 4 again. So 1, 2, 3, 4. So that's a negative 4. And then I'm going to go left. 1, 2, 3, 4. So that's also a negative 4. Well, if I want the new point, I'm going to double what I just did. I'm multiplying by 2. So now, instead of going down 4, my new point should be down 8, left 8. All right, I'm just doubling what we just did. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This should be what we would call B primed. And then as best you can, we should be able to draw that in. And then, I don't know if I can make a nice straight line here. Not too bad. I've done worse. All right, so just visually, does that look good? Does that look correct? Yeah. You can count it off real quick. I mean, those angles, you can kind of look. Those angles, we're going to assume a little bit. Certainly that bottom, the B angle is a 90-degree angle. But now what we just did at the top of that paper to confirm it, let me clean mine up just a bit here so it's nice and clean and we can count them. This. All right, so now let's kind of confirm this. If I go to the black triangle, it is 1, 2, 3, 4, 5, 6 units long. If I go to the blue one, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did we double that size? Yeah. If we go to the bottom, 1, 2, 3, 4, 5, 6, 7, 8. The blue one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. This one's a little harder because it's not along the vertical or horizontal line, but since those two are good, that one obviously is going to be the same as well. Okay, so that's how we would sketch those in. All right, number 3, this is what we would have called an enlargement because we multiplied by a number greater than 1. We're going to do the same exact thing in number 3, but our dilation should now be a reduction because now our scale factor is going to be a 1/2. All right, so I'll do this one together too. It's first reduction we've done, first getting smaller, but it's the exact same process. If I want to go from 0, 0, where I'm centered, and you have to go from 0, 0, that's where I'm telling you to start from, to point C, you would again go up 2, left 4. So that point is positive 2 over a negative 4. Well, now if I'm only going to go half the distance, isn't going half the same as just dividing by a 2 now? So now we're just going to do half of what we just did. So instead of going up 2, now I'm only going to go up 1. And instead of going left 4, now I'm only going left 2. We're going half the lengths. I'll do this one in green here. All right, so now that one. Go up 1. I'm sorry. Yeah. Go up 1 and then left 2. So this should be C double prime. So this one you're going to mark with the 2 tick marks. And just because I'm telling you to do that right here. All right. Then if I want A primed, for A, we said we went down 1, 2, 3, 4. And then we went left 1, 2, 3, 4. Now I only want half of that. All right. So half for the new point would just be down 2, right 2. So for this new one that I'll do in green, now from 0, 0, I'm going to go down 2, right 2. This would be a double prime. And then last but not least, if we come down here to B, we said we went down 4, left 4. So B we said is down 4, left 4. So now instead of going down 4, left 4, we're just going to cut those changes in half. Down 2, left 2. All right, so down 2, left 2. This would be B double prime. And when I now connect this, that should be our new triangle that just got cut in half. All right. All right. Good with that? I think we can follow that. Okay. All right. Then go to the next one. And it says, find the dilation of quadrilateral ABCD. So that's the one that we are given. Your center is point P, and we want to dilate that original quadrilateral so that we have a scale factor of 2. All right. So again, now we have to start from this point right here. Whatever you're told the center is, that's where you're going to count. So if I'm going to find, let's say we wanted A. If we found A, the slope of A, I'll try to organize this a little better here. So now we got 4 different ones to count off. To go from point P to point A, we would have gone up 2, left 1. So point A is up 2, left 1. Therefore, if I wanted A prime, the new A, and my scale factor is a 2, that means I am going to double that. Get rid of this. Right, give me a minute here. There we go. All right, so A prime now would be 4 over a negative 2 if our scale factor is 2. So now our new A, go up 4, 1, 2, 3, 4, and then left 1, 2. Put a big fat dot right there. That should be my new A point. All right, and then A is done. When we go to B, to go from this point to B, you would now go up 2 and then right 1, 2, 3, 4, 5. So up 2, right 5. So that slope would have been 2 over 5. So if I now want B primed, I'm doubling it. So my new count will be 4 over a 10. So go up 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then that should be the new point B. The original C, we would go down 2, left 1. So down 2, left 1. So negative 2 over a negative 1. C prime is just doubled that. So now we're going down 4, left 2. So 1, 2, 3, 4. 1, 2. And that is C prime. And then last but not least, to get to D. Oh, wait. I screwed that up. Sorry. That's D. That's D. That's D. That's D. That's D. All right. Last one is C. All right. So change this. All right. C. We go down 2 and then right 1, 2, 3, 4, 5. So down 2, right 5. Scale factor of 2 means we're just doubling those counts. So I'm going to go down 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, you should be able to tell if you did this right or not. Notice how we get a rectangle. If you counted up all those side lengths, one should be twice as big as the other. Also keep in mind, this is another little unofficial check. Notice how the center here, A and A prime, all line up perfectly into a straight line. I don't want you to draw it in, but just kind of understand it. Our center and then D and D prime all line up in a straight line. C, same thing. And then the B's, same thing. Notice how those all line up perfectly if we did that correctly. Okay, so that's another way you can kind of check before you were to tan something in on a quiz or a test if you did it right. All right. Okay, so real quick, do 6. At least, yeah. Don't worry so much about this. Go ahead and sketch that in. So draw in a triangle. This is our original triangle. Your center is 0, 0. We want a scale factor of 3. Right? Typically, people don't find this terribly hard. So we've done a few now. See if we can kind of figure out what that new one would look like. Let me make this bigger here. And then when you connect the 3 new points, you should probably be able to tell if it's right or not. Do me a favor, do the ups and downs first, just because slopes are always good. Okay, so you go down 2, left 1. So now I'm going to triple that. So they're going down 2, left 1. Down 2, left 1. So now my scale factor is 3. I want to triple what I just did. So instead of going down 2, left 1, I go down left 1. And then do that. That's where you would put you inside. That would work. Sort plot first. And then they will go. No, that. Yeah, it's just a new point. You have to extend it. So you could say it went up to one. Right. Remember how we wanted to class it in there, we could change the orientation of everything? You just kind of went, you took this fraction, you're still on one, since you went up to right one, right, three, okay, so you can go six, set up here, two, what did you, that so right, scale factor, so we do the same thing, one, so right three, so it's one times three, and then you went up six, right three, and then three times three is all from this point. So you would go up three right now. Yeah, the only issue is going to be that's not something to do. Yeah, I probably do that. Label your points though. Label the new points in that table, just to kind of show that it works. Okay. All right. When we did these now, so we can do these real quick. This you would have gone. The first one would have been down 2, left 1. We want to triple that. So you would go down 6, left 3. So down 6, left 3. That point then is now -3, -6. That's where that new point for that one ended up. When we go to this point, I would have gone down 1 and then right 2. So over here, for this point here, we would have gone down 1 and then right 2. Now we triple that. So now I want to go down 3, 1, 2, 3, and then right 1, 2, 3, 4, 5, 6. And then last but not least, that point 3, 1, we would have gone from 0, 0, we would have gone up 1, right 3. So we would have gone up 1, right 3. A scale factor of 3 means I'm going to triple those counts. So now I'm going up 3, right 9. So up 3 and then right 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. If we draw these in, again, just visually, we should look at that and see that, yeah, that's probably right. Those look very similar. They're oriented in the same direction. If we didn't screw anything up, all right, that should be good. Now, look at these points. So I've already labeled this one. The 0.31 became the 0.93. This 0.2 -1 became this point right here, which is 6 -3. The reason I wanted you to do that, it says, what do you notice happened to the ordered pairs compared to the original? So if we look at this original ordered pair to this one, the original to this one, and the original to this one, what happened from the left-hand point to the right-hand point in all of those? All right, Armando. Good. Didn't X and Y, didn't we basically take 3 and distribute it to both the X and the Y coordinate? 3 times a -1 would have given us a -3. 3 times a -2 would have given us a -6. If I did 3 times 3, 9. 3 times 1 is a 3. Well, notice what our scale factor was. Wasn't our scale factor simply a 3? So that is not a coincidence in terms of what we could have done in order to make that happen. All right. So in terms of 7, all of those got multiplied by a 3. All right, which just happens to be our scale factor. That's what a scale factor is. What are we consistently multiplying by that entire time? All right. All right. So real quick, go down to this one so that we can do this here. It says in the diagram to the left, what are the coordinates of point B and D? So here's point B. Point B has the coordinates X is 4, Y is a 3. So just write down those coordinates. If I ask you what point D is, point D, this point right here, has an x coordinate of 6. We're eyeballing a little bit. I promise I wanted that to be 4.5. So make that 4.5. All right, then I ask you, is triangle ABC, so is this small triangle right here, similar to the big triangle A to D to E? All right, so we have a little one within that big one. All right, well, a couple things. For one, the corresponding angles are definitely congruent. Like these are both 90 degrees right here. This angle down here, they're sharing. So this is the same angle for both of them. These are both 90, so then these are going to be the same. So you're going to say corresponding angles are congruent. So we've checked that box. The other thing that has to be true is their ratios have to be the same. So look at the bottom of the red triangle. The bottom of the red triangle has a length of 4. The bottom of the green triangle has a length of 6. Look at the right-hand sides. The right-hand side of the red triangle is 3. You can just count off those blocks, so there's 3 of them. The right-hand side of the green triangle is 4.5. Now, might not be obvious because 3 divided by 4.5, you may not have kind of an idea of what that is equal to. But definitely 4/6 is 2/3. The number that goes into both of these, so we'll think about money. What is $3 divided by 1.5? So $3 you divide, everybody gets 1.5. What does that give you? 2, right? If you have $4.50 and everybody gets $1.50, doesn't that divide equally into 3? So do these guys end up with that same exact ratio? Yeah. Okay. So this, we would say, yes, these triangles are similar to each other. All right. All right. Real quick, number 10, answer that question. Look at the graph, find the point 12.9. Tell me if the point 12.9 is on that line. All right. All right. Yes or no? Is 12.9 on that line? Yeah. This is a yes. We can just look at it here and tell. Here's 12.9. If I plot the point 12.9, it just so happens to be on the line. Here is why it is on the line. Take the original point that we were given, the point 4,3. So this guy right here. The reason it is on that line, what number could I multiply by 4 to get 12 and multiply by 3 to get a 9? 3. So if I multiplied each of those by a 3, notice how I get the point 12,9? That's how we know it would be on that line. So when we go to 11, the line can't be seen anymore. But I want to know if 28, 21 would be on that line. And the way we would kind of figure that out is take the point 4,3. What would we multiply 4 by in order to get a 28? 7. If I multiply 3 by a 7, would that give me a 21? Yeah. So this just simply means our scale factor would have been a 7. And yes, we would have ended up on that line. All right. Last but not least, this guy. If this is on the line, it should be the same scale factor from that original point that we knew, 4,3. What do we multiply 4 by to get 36? 9. So would 9 times 3 then give me the 30? No. So this one would not be on that line because this would now give us a 36, but our y coordinate now is a 27. Okay. So the scale factor isn't the same for both the x and the y. All right. Okay. We'll see how this goes. And then if everything goes reasonably well with this, hopefully this isn't too bad. Save some time. That would be your homework, and then we'll hopefully quiz on Thursday then. It does save some time, I guess. Yeah. Oh, and I'm recording too still.